This lesson looks at factoring trinomials and a specific type, and that is when we say something that a is equal 1. I'll explain that in a little bit. Before we get too far with factoring, another factoring technique, one other thing just to consider, again, is what the word trinomial means. That means we have 3 terms. So we'll look at that in a few minutes. But before we do factoring trinomials, we're going to go ahead and review multiplication, which is the opposite kind of process that we're doing. So number 1, we see a multiplication problem. So number 1, we have multiply. We have 2 expressions, 2 factors that we're going to multiply together. And it says show our work. So we're going to go ahead and multiply those. So we have c to the third times c to the third, which is c to the sixth. C to the third times negative 9 is negative 9c to the third. We'll do the same thing with distributing negative 5. So it's negative 5c to the third, and negative 5 times negative 5 is positive 45. Then after we distributed, we'll go ahead and combine like terms. So those two right there. So we have c to the sixth, and we'll combine negative 9c to the third minus 5c to the third, and that is negative 14c to the third. And we can't combine that constant with anything, and so we are done. Just bringing that 45 down. So a couple of observations that we get there. So one, how did we get that 45? That 45 right there. We got it by multiplying. So we need to think about this constant out here. We did it by multiplying 2 numbers. And the 2 numbers we multiplied were negative 5 times negative 9. And then a follow-up question, how did we get negative 14? We got negative 14 because we combined these two, that negative 9 plus a negative 5. And again, those numbers are the same numbers that are up there. So this number right here is actually a sum. It's the sum of negative 9, really c to the third, minus, or we can say adding a negative, either way, adding a negative 5. So we see that it's the same 2 numbers, but one is a sum and one's a multiply, and we got to figure that out when we go backwards. So when we go backwards, we're going to look at this this expression, this trinomial expression, and we're going to try to find numbers that multiply to be 45, but they also have to add up to be this middle term right here of negative 14. All right, so number 2, it kind of is some baby steps, I guess, on thinking about that. So if we have this expression, we want to find what 2 things multiply to equal that. So we have b to the 8th minus 13b to the 4th plus 42. So we're looking for 2 numbers that multiply to be 42, and they add up to be negative 13. And those 2 numbers are already given to us right there. If we do negative 7 times negative 6, that multiplies. So when we multiply those 2, we get positive 42, and then when we add them, we do get negative 13. So the other thing to consider is what goes in this first part right here. We need 2 things right here to multiply to be b to the 8th. So we already started off b to the 4th. The other one is also going to be b to the 4th. So when we're looking at those exponents there of that first term right here, this first term, they do kind of split in half. Equally. Number 3 explores the same idea. So again, n squared minus 5n minus 50. That is equal to 2 numbers or 2 expressions that we multiply. And so I already gave you a hint. This should make sense. N times n is n squared. So that should make sense. So now what we have to figure out is what number is over here. So again, we want to multiply this 5 times something, and it's got to equal negative 50. So let's try that. So if we, I guess we can divide, but that's going to be negative 10. So again, because 5 times negative 10 is negative 50. Let's double check. Let's actually add those together also. And that is negative 5, which is right there. Okay, so again, we're looking for a set of numbers. So 5 and negative 10. They multiply to be this last term, that constant, and they add up to be the middle term. All right, so this text box kind of describes when we're going to do this, and then gives an example of that process when we're not getting hints like number 2 and 3. So again, this is for trinomials. So there's 3 terms. It's got to be in this format here. So we have 2 different exponents. So x to some power and x to another power. But the relationship of those 2 is n has to be half of m. Also, this technique that we're using, this first leading coefficient of that first term, that's if it's in standard form, that has to be 1. If it's not 1, that's another way of doing it, and we'll talk about that another day. All right, so for example, so we have x to the 10th minus 2x to the 5th minus 24. So we're first double check. It is, we'll look at those exponents. 5 is half of 10, so we can, and it's a trinomial, so we can go ahead and use this technique. All right, so what we're going to look for are numbers that multiply to be negative 24. So here I just listed all the factors. Here's all the ways that we could multiply to get negative 24. I guess there's more. We could also do negative 1 times positive 24, negative 2 times positive 12, so that there are some more. But I only did those ones because we're going to go ahead and add all of those. So 1 plus a negative 24 is negative 23. So we add those until we find the one that's this middle coefficient, and that's negative 2. And you can see that's where I stopped at that last one. Okay, so 4 times negative 6 multiply to be negative 24, and they add up to be negative 2, and that's this right here. All right, so those are our two numbers that we'll use in our factor. So we just kind of bring them down right there and right there. And again, for the first x's right there, we have to multiply 2 things to get x to the 10th. So basically, we're just really splitting those into 2 equal groups. So x to the 5th times x to the 5th is x to the 10th. All right, so a couple of hints when we're looking at c, and real quickly, c is that constant at the very end. So if c is positive, so if that last thing's positive, then both factors, how are we going to get a positive number when we multiply is the idea. Okay, so we're looking at multiplication. So what two numbers, when we multiply 2 numbers, if it's positive, they're going to have the same sign value, because you're either going to have a positive times a positive, right? And that'll give you a positive c value, or you're going to have a negative times a negative. That also equals a positive. Okay, so if the c is negative, then both factors have to be different. So one's positive and one's negative. So that's like our example up there. That c value, again, that's that constant right there. That c value was negative. And so if that's negative, you'll notice that all of our factors, one has to be positive, one has to be negative. All right, again, the second exponent must be half of the first exponent. All right, so a few more just practice problems along those lines. So like on this one right here, we're going to go ahead and list all the factors of 42. So if I look at that c value, again, that c value is positive. So it's either going to be a positive times a positive or a negative times a negative. If that c value is positive, we can go ahead and look here, and that will tell us which we're going to use. We're going to do a negative times a negative. And the reason why, again, is because they need to add up to be negative 13. So we were going to look for a sum. The sum has to be negative 13. Okay. Now, some of these, they can just pop in your head, and you can just figure them out. So like, you may just look at that and go, all right, I know that's going to be x minus 7 and x minus 6. Because if I multiply those two, I get positive 42. And if I add them together, I get negative 13. And that's fine to do it that way. But if you get stuck, you're going to make a list. Okay, so either technique is fine, but be able to at least make a list. So we can do negative 1 times negative 42. And if we add those together, we get negative 43. All right, and then, sorry, negative 2. So if we divide that 42 by 2, that is 21, negative 21. If we add those together, that's not quite what we're looking for. All right, we can do negative 3. So 3 does divide into 42 14 times. So if we add those together, we get negative 17. Try negative 4. 42 divided by 4 is going to be, actually, does 42 work? 42, it does not work. We can't divide by 4. We can't divide by 5, so let's try 6. So that's going to be negative 6 times negative 7, and that one is negative 13. Okay, and that's our combination. So again, those are those two numbers that we're just going to go here, and the order doesn't matter in which you multiply, so we can do that. So we can say that if we multiply these two things, we get this expression right there. All right, a few more examples. So number 5, we're going to go ahead and do that. So now we're looking at numbers that multiply to be 24. So that's the product right there. So we're looking at two factors of 24, and then their sum has to be 10 to the third. So we can start this real quickly. We know it's got to be, that first term has got to be x to the third, because when we multiply them, x to the third times x to the third is x to the sixth. Okay, and notice also the exponents, that's 6, the next one's half, so we can go ahead and use this technique. All right, so maybe you can think on your own, just, all right, what two things multiplied to be 24 that add up to be 10? If that pops into your head right away, go for it. Let's help us out with the sign values. So if that's plus, they're going to be the same. So it's either a negative times a negative or a positive times a positive. If they are the same, that second one's going to tell you. So we know these are both plus. Okay, so we can just start listing them. 1 times 24. Okay, when we add those together, we get 25. 2 times 12. That's when we add them, we get 14. Okay, we can do 3 times 8. Okay, and that's 11. 4 does divide into there 6 times. Oh, there it is. There's our sum of 10. So plus 4 and plus 6. And again, the order doesn't matter in which we put those. All right, a couple more examples. These are just an additional step. So number 6, we actually skipped this. We should do this on every single factoring problem. The first thing you look for is GCF. Okay, so we're going to see if we can divide all of those by something. All right, so that first step, what is the biggest thing I can divide each of those terms by? And that's 2x to the 5th. Okay, and once I do that, I'm going to go ahead and divide the GCF into each term. So when I do that, I get x squared. 2 into 18 is negative 9x. X to the 6th divided by x to the 5th is x. And then 2 into 180 is 90. Whoops, and we keep the sign values the same. Okay, and then we're going to go ahead and factor that. So the trinomial. So we're going to bring down the GCF and say, all right, we're going to find two things on here that multiply to be x squared minus 9x minus 90. So it's just like what we did before. So this has to be x times x to get x squared. This sign value is negative, so to multiply to be a negative, one has to be negative, one has to be positive. And so again, if it pops in your head, go for it. So we're all the ways to get negative 90. We can do 1 times negative 90. We can do 2 times negative 45. We can do 3 times 30. And we can add those as we go. Hopefully you're seeing that those ones don't work. 4 does not divide into 90. 5 does. 90 divided by 5 is 18. If we add those, we get negative 13, so that's not what we're looking for. 6, we can divide 6 into 90, and that is 15. So 6 times negative 15, not quite there. So you can see that this could take a long process if you're not great with those. Oh, I'm sorry, on this one that does work, so negative 90. So if we add those two, we do get negative 9. Okay, so negative 15 times 6. So you just kind of have to exhaustively go through all the factors until you get your answer. Sometimes it'll happen right away. Sometimes there's quite a bit of work to do. All right, number 7 has just one little step at the beginning. Again, we talked about that a value has to be 1. So if the a value is not 1, like on number 6, that's probably the GCF right there. Okay, so on number 6. On number 7, again, that a value, the coefficient of that first one, has to be 1, and it's not 1 on this one. It's actually negative 1. So we're going to factor out a negative 1. And so when you factor that out, you're really just dividing. So we're going to divide each term by a negative, which does change the sign values. Okay, so that's kind of like the GCF. All right, so we're going to go ahead and find two things that multiply to be this. So we know it's got to be a times a to get a squared. All right, we want two numbers that multiply to be 36 that add up to be negative 13. So to get a sum of a negative by a multiplication that's positive, they both have to be the same sign value, and we can just start listing those factors right there. Okay, so you can do really negative 1 times negative 36, negative 2 times negative 18. That one adds up to negative 20. Negative 3 times negative 12. negative 4 times negative 9. Oh, that one right there. If we add those two together, whoops, times 9, we do get negative 13. Okay, so those are our two factors right there. All right, now we're going to transition. We're doing the same thing, but now we're going to solve by factoring. Okay, and we solve whenever there's an equation. And when we have equations, we're rewriting the equation. Each step is a new equation, and it's no different than what we've just been doing. You have two extra steps. One at the beginning, we're going to make sure this is in standard form. So I'm going to, in other words, make sure that equals 0 as well. Okay, so that's one step at the beginning on some problems. And then we're going to factor it just like we've been doing. And then the last step is we're going to separate each factor, set it equal to 0. Okay, so we want two things that multiply to be negative 40, but add up to be 16. So, and then the first one, x times x is x squared. Since this is negative 40, one's positive, one's negative. So, and again, the order in which you write those is not that important. So maybe you can like look at this one and go, if not, you do your list, but maybe you can look at this one and go, all right, that's 4 times negative 4 times 10 is negative 40. So that worked out. And then if I add those together, I get positive 6. So those are our two factors right there. Okay, so when we factor them, again, sometimes it's guess and check, sometimes you make a list. All right, so we had one step at the beginning, set it equal to 0, then we factor it. So from here to here, make sure it's in standard form. So convert to standard form, then you're going to factor. Okay, and then after that, this whole expression will be 0 if either of the factors are 0. So everything with the x, we're going to set equal to 0. So we add 4, and then we subtract 10, and those are our two values of x. So again, we do this on equations. Notice every single step, there is an equal sign, even with our answer. Okay, that's different than these ones. On 5, these expression, we're just saying this expression is the same value as this expression. It's just like saying 6 is the same thing as same value as 2 times 3. We're not solving, we're just rewriting it. All right, and the last one for solving, it is in standard form, so that's good. First step so now we're going to move on to factoring. The first thing on factoring is we always do greatest common factor. Okay, so the biggest thing we can divide each of those terms by is 2x squared. So we're going to divide that into every single one of those terms. So 2 divided by 2 is 1. X to the 4th divided by x squared is x squared. Divide the next one by 2, and the last one by 2. Okay, so one step for doing greatest common factor, and then so that factor comes straight down, and then we're going to go ahead and say that that trinomial, those three terms, can be split up as a product of those two factors there. So it's got to be x times x to get x squared. All right, two numbers that multiply to be negative 30. So one's positive, one's negative, but then their sum has to be negative 7. So again, you can start listing them 1 times 30, 2 times 15, 3 times 10 until you get it. So 3 times negative 10 does multiply to be negative 30. And when we add those, we also get negative 7. Okay, so those are our two numbers, so negative 10 and positive 3. Okay, so once we're done factoring, we're going to set each of those factors with an x equal to 0. So this one right here, 2x squared equals 0. Next factor, x minus 10 equals 0. X plus 3 equals 0. Okay, again, factors are things we just multiply. All right, so 2 times something squared is 0, so x has to be equal 0. The next one, 10 minus 10 is 0, or you can add 10 algebraically if you want to think of it that way, and then subtract 3, so x equals negative 3. So on this one, we had 3 answers because there was 3 different factors with x. Okay, so again, when do we use this technique? It's when there's 3 terms, they're trinomials, and that leading coefficient has to be 1. Sometimes it's kind of disguised, like on number 9, where we have the 2 out in front, but we always do GCF first. So after we do GCF, if that leading coefficient is 1, this is where we're going to do that technique of finding the sum, the two things that multiply to be C, and then they add up to be that middle term b.